Okay, so 3.2 is proving figures are congruent using rigid motion. So confirming congruence, we can either do it by transformations, or checking length of each side. So in this section, they want you to use transformations, finding sequences of transformations. So two plane figures are congruent if and only if one can be obtained from the other by a sequence of rigid motions. So let's determine if these figures are congruent. Use the definition of congruence to decide when the two figures are congruent. If they are congruent, what kind of transformations is it, and what is the rule? So if you look at A, they look the same. So let's see if we can figure out what kind of transformation moved it. The first thing I'm going to tell you to do is to think about which letter corresponds to which letter. They don't use the prime notation. So C, D, E, F, that's the alphabetical order. And over here we'll have J, K, L, M. So C, D, E, F. They both go in alphabetical order. Okay, and so you're going to start with the first one in the bunch. So it's kind of easy to see that this was a reflection, right? So reflect across y-axis. And if we want to write the rule, xy goes to, and let's check one of them. I'm going to check F because it is, or D, we could do D. So D was at -8, not -2, just +2. These lines go by 2 apiece. And then that was D. And it goes to K, which is at 8, +8, 2. So it looks like we get XY goes to opposite XY. And that's our rule. Okay, so we'll do B in class. And then it says your turn. Use the definition of congruence to decide whether the two figures are congruent. Explain your answer. So again, if I'm looking at A, B, C, D, it is going to go to, it's going to map to, let's see, W, X, Y, Z. And I like to write the letters W, or A, B, C, D. So when I look at that, I can tell that it's going to be a reflection across the x-axis, and the rule would be XY goes to, and let's try this. A is at 4, 8. And W is at 4, -8. So my rule is going to be X opposite Y. We'll do 3 in class. Now these examples, they are congruent. It tells you that already. And it says, find a sequence of rigid transformations that maps one figure to the other. Give the coordinate notation for the transformations you use. Okay, so the first thing, and here it's labeled, it gives you their names. And so you know that A maps to P, and I'm going to write it on it because for me it's just easier to see. B maps to Q, and C maps to R. Okay. So if I spin it, I can see that A is going to be out to the right, and B is up, and C is to the left. So let me spin it back. And that's exactly what it's at. So I know it's a rotation. And I'm moving 2 quadrants, 1, 2. So that's a rotation, 180 degrees rotation. Okay, and so let's map one of these. So A starts at -8, -2. And if I do a 180 degree rotation, I'm going to say out 8 over 2. So I'm going to go this way, out 8, up 2. And it puts my A right there. So then it looks like, so my new A, the first A, would be at 8, +2. But my final A, or P, if you will, has to be at, what is that, 9, 2. So after the 180 degree rotation, that's our first thing. Our second thing is going to have to be to move right 1. So horizontal translation of 1. Okay, so my rule is going to be XY goes to opposite X, opposite Y, goes to X plus 1 Y. Okay, and we are going to do those other 3 in class. So that's all for 3.2.